We've covered how to reverse a string using 2 pointers, but what if we had to be picky and only reverse certain letters? In this tutorial, we'll dive into regex, multiple loops, and more. This is AlgoDaily. Hey everyone. Suppose we're given an input string containing both alphanumerical characters as well as symbols. So we may see elements like B, F, D, C, E, A, clearly letters in the English language, as well as numbers like 2, as well as symbols like exclamation, star, dot, etc. Let's say hypothetically we're asked to only reverse the alphabetical characters. So in taking this top input string, we reverse it and we skip 2, we leave 2 where it is, we reverse A, reverse E, reverse C, D, F, skip the exclamation point, and reverse B to get this. How might we tackle this problem? Well, to begin, let's think about how we would reverse a string regularly. So we've covered this in the past in how to reverse a string, and we found out that the preferred approach is via a 2-pointer pattern, where we can easily reverse 2 characters at a time by doing a swap and then moving inward and then doing a swap again, and then moving inwards one more time and doing a swap. And finally, we reach the midpoint until we can't swap anymore. And that'll give us the final output. In this case, though, we need to find some way to delineate the exclamation point and the 2 and only focus on the alphabetical characters. Let's review this example in another format. We're given the array B, exclamation point, F, D, C, E, A, and 2. Originally a string, we've already split this up into an array. What we want to accomplish is to reverse only B, F, D, C, E, A, and skip exclamation and 2. In order to distinguish the alphabetical letters, why don't we explicitly make it clear that they're alphabetical by storing them separately? This is the brute force approach. In a temporary array, as we iterate through the original array, we can push each alphabetical letter into the temporary array. So we push B, we skip the exclamation point, we move on to F, push D, C, E, A, O get pushed, and we skip 2. Because we want them sorted, we can just reverse the temporary array. So B, F, D, C, E, A gets reversed, and we get A, E, C, E. Oops, this should be a D. So B, F, D, C, E, A gets reversed, and we end up with A, E, C, D, F, B. Now, what we can do is traverse through the original array one more time, and each time we stumble upon a letter of the alphabet, we can replace it with the letter in the same position as the temp reversed array. So instead of B, we'll have A. We see the exclamation point, and we keep it. Then instead of F, we'll push E. Instead of D, we'll push C. Instead of C, we'll push D. Instead of E, we'll push F. And instead of A, we'll push B. And then when we get to the 2, we'll stick it back in. And ta-da! This is the array that we want. Of course, this is a little bit slower than what we would want because not only do we do two loops to identify where the alphabetical letters are, and then another loop to fill them back in, we also have to sort this array separately, as well as maintain enough space to store the temporary array. Let's examine how the function looks when we use a temporary array. So the function signature is kept the same, reverse only alphabetical, takes in an input string. We set up our temporary array here, we call it alpha cars. We do a split on the string so that we get an array that we can operate on. We iterate through the array, and we use this regex to test if it's an alphabetical character. And if it is, we push it to the temporary array. Then we have this helpful reverse array method that we'll call on the alphabetical characters. And all it does is it uses the two-pointer approach to constantly swap until we have the array reversed. And then we initialize a separate pointer to help us keep track of where we are in the alphabetical temporary array. And then we iterate through the original. And if we see an alphabetical again, we assign that slot to the index at that reversed array. Finally, we join the array to get the string that we want back. We have J, exclamation point, star, and E. Notice that at this point we've already split up the string into an array to make it easier to operate on. In trying to get this below output, we'll notice that if we do a swap of J and E using the two-pointer reversal method, we end up with E and J. And then when we move inwards and we recognize these two characters, we no longer need to do anything since they're not alphabetical. So let's analyze the function using the two-pointer approach instead of creating a temporary array. So we can skip the temporary array by using a left pointer and a right pointer, one beginning at the start and one beginning at the end. And it's the same as the two-pointer approach for reversing a string, starting at the left pointer. While the left pointer is less than the right pointer, if the character at the left pointer is not a letter, not an alphabetical letter, then we iterate. Because if it is an alphabetical letter, we want it to get here and swap. So if it is not an alphabetical letter, if it's an exclamation point, or if it's a dot, or if it's a semicolon, then we skip. Same with the right. If we see a symbol, then we skip and we continue moving inwards. And only when we see that both characters are alphabetical do we make the swap. And notice here, even at the swap, we still continue to increment and decrement because we need to keep moving inwards regardless of if we've swapped or not. And of course, we ultimately join, and I'll show you the two helper functions here is alpha. This is a handy way to know if a character is a letter or not. And of course the swap method. And then just a simple log so we can test it. So let's go ahead and try it out. And boom, we get what we want.